Hello viewers, welcome to Quick Mathematics. The problem is evaluate using logarithm tables to two decimal places. We have the fifth root of 0.364 times 0.0489 divided by 3.96 bracket close to the power of 3. It is clear that the power of 3 is affecting everything. So you have to resolve everything in the bracket before you take the power operation. Let us take the quick solution to this problem. Solution: this is the whole problem as given. Now I want to break it into three parts for you to understand it easily. The first part is everything under the fifth root. The second part, you take the fifth root of the first part, which means divide the result from the first part by 5. Part 3 is to take cube of the second part, and that means that you multiply the result from the second part by 3, because you know power operation implies multiplication of the log value by the given power. Root operation implies dividing the log value by that root, which is 5 in this case. So we go to part 1. In part 1, we consider the numerator, number by number. So the first number there is 0.364. This is what happened. To get the log, we do two things. You find the characteristic or integer and the multiplier. When the number is less than 1, you get the characteristic by standard form. If you put the number in standard form, the power to base 10 is the characteristic. So if you write this number in standard form, you are going to have 3.64 times 10 to the power of minus 1. So minus 1 written as by 1 is the characteristic. That is by 1. For the multiplier, you check 36 under 4. There is no difference because you don't have fourth digit. In the logarithm table, the difference column is for the fourth digit. So in this number, there is no fourth digit. You simply check 36 under 4 and you have 5611. The second number is 0.0489. I want to get the characteristic by using shortcut. The shortcut is to count the number of zeros before the first non-zero number. The first non-zero number is 4. You have 2 zeros before it. That means we have bar 2 as the characteristic. For the multiplier, you check 48 under 9. That gives 6893. The numerator is multiplication, which implies addition of log values. So you add together. 1 plus 3 is 4. 1 plus 9, 10. You put down 0, you carry 1. 6 plus 8 plus the 1 you carried forward is 15. Put down 5, carry 1. 5 plus 6 plus the 1 you carry forward is 12. Put down 2, carried 1. Then the point will be the same position when you are adding or subtracting decimal numbers. So we have bar 1 plus bar 2, that is bar 3, plus the 1 you carried forward, you have bar 2. The denominator is 3.96. This number is greater than 1. To get the characteristic, you subtract 1 from the number of digits before the point. You have 1 digit before the point. If you subtract 1 from it, you have 0 as the characteristic. For the mathisa, you check 39 under 6, no difference. You have 5, 9, 7, 7. So we take the whole of part 1. Part 1 is division operation, which means you subtract the two numbers, the result from numerator and the result from denominator. So let's take the two results forward. This is the result for numerator and this is the result for denominator. Because the first number is negative, that is bar 2, we have to check if you can subtract without doing any other manipulation, that is genuine one. So to check, you take the first number after the point, that is 2, and you check it with this 5. Clearly 2 minus 5 cannot, so you need to borrow 1 from bar 2, and you cannot borrow from negative. Now you ask yourself, that one that you need, what will you add it to give you bar 2, that is bar 3. So you write bar 2 as bar 3 plus 1. You have created that one that you need to borrow. Then you can subtract. When you subtract, 4 minus 7 cannot. Borrow from 0, you cannot. You come to 5 and borrow. When you borrow from 5, 5 becomes 4. That one you borrow, you take it to 0, it becomes 10. You need to borrow 1 from 10 again. That place remains 9. You take down 1 to 4, becomes 14. Minus 7 is 7. Then 9 minus 7 is 2. 4 minus 9 cannot. You come to this 2 and borrow. 2 remains 1. If you add that 1 to 4, it becomes 14. Minus 9 is 5. You have 5. Then the 1 remaining in place of 2 now, minus 5 cannot. So you come and borrow this 1. So nothing is there. You add that 1 to the 1 in place of 2 now, it becomes 11. Minus 5 is 6. So 0, 0 means nothing. So here you are left with bar 3 minus 0 now. That is bar 3. This is what you have. So this is the result for part 1. Bar 3.657. We take the second part, that is the fifth root of the first part. Fifth root means you divide the result from the first part by 5. Now this is what happened. Assuming this bar 3 here is ordinary 3, that is positive, if you divide 3 by 5, you can say 0 remainder 3. But it is bar 3. If you divide bar 3 by 5, would you say bar 0 remainder by 3? No, it's not done that way. So you ask yourself, which number can you divide 5 with to get by 1? You consider this 5 when you are thinking about the number. That number can only be by 5. So you have by 5. Again, you ask yourself, which number will I add to by 5 to get by 3, the original number? That number must be 2. So you transform by 3 to by 5 plus 2 to enable you divide. If you divide by 5 by 5, you have by 1. If you divide 2 by 5 is 0 remainder 2. That 0, if you add it to by 1, you still have by 1. Then the points follow. If you take that 2 to the position of 6, it becomes 26. Divide by 5 is 5 remainder 1. You take remainder 1 to the place of 5, it becomes 15. Divide by 5, you have 3. Nothing is left. Divide 2 by 5, cannot. That means 0 remainder 2. Remainder 2, you take it to join 7, it becomes 27. Divide by 5 is 5 remainder 2. If you wish to continue, because of the point you have there, you add 0 to remainder 2, it becomes 20. Divide by 5 is 4. That is the result for part 2, taking the 5th root. So you take the cube of part 2, that is multiplying the result from part 2 by 3. Power operation implies multiplication of the log value by the power you have. Hello. So we multiply by 1.53054 by 3. Now in log table, the table is programmed to 4 decimal places. So actually we don't need this 4. So let's start from 5 now. You know, when multiplying, you start from right to left. So 5 times 3 is 15. Put down 5, you carry 1. 3 times 0 is 0. Plus that 1 you carry, you have 1. 3 times 3 is 9. 3 times 5 is 15 remainder 1. 3 times by 1 is by 3. Plus that 1 you carried, you have by 2. You have by 2. So the final answer is to check the antilog of by 2.5919. In antilog, we are interested only in the decimal part, that is 0.5915. In the antilog table, you check 0.59 under 1 difference 5. That gives 3904. Come back to this place. I told us that the bar 2 you have there is because of the 2 zeros before 4. So here, this bar 2 simply means you should have 2 zeros behind the number. That is the 0, 0 you have here. So the point is between the first 2 numbers here, between the first 2 zeros. So you have 0.03904. You are asked to leave your answer to 2 decimal places. So you are interested in 03. You look at the next digit 9. 9 falls in the category of digits that you need to round up to 1. If you round 9 up to 1, you add it to 3, it becomes 4. So you have 0.04 to 2 decimal places. Hello, Peter Course Simplified Maths. If you are viewing from YouTube, subscribe to the channel, like and share PSM videos. If you are viewing from Facebook, follow and like the page. Also share PSM videos. Goodbye.